In this video, you will learn how to model data by using linear and quadratic regression. So what is a linear regression model? Well, what it is it's the process of finding the linear equation of best fit for the given data. So what does that mean and what does that look like? Well, let's take a look at an example to illustrate. Let's say that a convenience store manager notices that sales of soft drinks are higher on hotter days, so he assembles the data in a table. Using a linear model, predict how many soft drinks he would sell if the temperature was 95 degrees Fahrenheit. So let's say that he collects all this data and puts it in this table right here, where the left column is the high temperature of the day in degrees Fahrenheit, and on the right column we have the number of cans sold. What we can do is we can translate each row into a ordered pair. So the first row would be 55, 340. The second row is going to be 58, 335. All right, and then do that for each of these different rows to get all these different points. And then we can plot these points on a coordinate graph. So notice right here is exactly what we have. We have our x-axis is the high temperature in degrees Fahrenheit, and the y-axis is the number of cans sold right here. So we plot each of those points and we get this graph right here. So what we can do is we can create a line. This is a line of best fit, or a trend line, that best represents the data that we've collected. And what this line is it's the line such that we have minimized the sum of the vertical distances or deviations squared. So if you take a point such as this one right here and calculate the vertical deviation, so how far it is from that line, and then square that, all right, and do that for each of these points, figure out the deviation vertically from this trend line. So find the deviations and then square that distance for each of these and then add them together. Or this line here is minimizing that. So there's a process you can use to find that line, to find the equation, but our objective is not to go through all the calculations, but to know how to use it, and then we will actually figure out how to get it within Microsoft Excel. But you could do it by hand to get the slope and then figure out the equation that way. All right, so for now we'll just show you how to use the line, and then at the end of the lesson we will show you how to do this in Microsoft Excel. All right, so once you have this equation of the trend line, there's a lot you can do with this. What you can do is you can predict different things with this. So here we're trying to use a linear model to predict how many soft drinks this guy would sell if the temperature was 95 degrees Fahrenheit. So we take that equation that we have found, and 95 is a temperature. That was one of our x values. So we plug 95 in place of x and see what we get for y, which would be the number of cans sold. So plug 95 in for x into this equation. We have 16.416 times 95 minus 621.83. And if you type that in your calculator, you're going to get y equaling 937.69. So if you round this to the nearest whole can, it's going to be 937. You can't have a fraction of a can, so we'll round down in this case, 937. All right, so we can predict that this store manager will sell 937 cans if the temperature is 95 degrees Fahrenheit. Now, another thing when dealing with regressions is a correlation coefficient. Okay, what this is it's a measure of how close the points of a data set can be modeled by the straight line. So we're trying to calculate the amount of correlation that the two sets of data have. And we use the letter R for correlation coefficient. And the closer the absolute value of R is to 1, the closer the data is to a straight line. So 1 is basically 100% correlation. -1 would also be 100% correlation. All right, so your correlation is going to be between -1 and 1, and then in the middle is going to be 0. So this would be like 0% correlation. Anything in between 0 and 1 is going to be positive correlation. Anything between 0 and -1 is negative correlation. And if there's positive correlation, that means the regression line is going to have a positive slope. And if there's a negative correlation, then there's going to be a negative slope. And the closer it is to 1 or negative 1, the higher the correlation. The closer to 0, the lower the correlation. So if you had a correlation coefficient, let's say of 0.1, well, that's closer to 0 than a 1. That's going to be low correlation, and it's going to be positive correlation. If you had r equals negative 0.9, for example, that's going to be high correlation because it's very close to negative 1. It's closer to negative 1 than to 0. It's going to be high correlation, but the negative means it's going to be a negative correlation. And what that means, positive and negative correlation, is positive correlation means as one set of values increase, the other set of values increase. So with the store manager example, as the temperature increase, the number of cans sold also increase. And we saw that the line that we had on the previous slide had a positive slope. It was going up like this. That was a positive correlation. Negative correlation would be the opposite, where as one value increases, the other value decreases. So for example, maybe the more miles you drive a car, the less gas is in the vehicle. So as the miles increase, the gas in the vehicle decreases. They're doing opposite things. So that'd be a negative correlation. And then if you take that correlation coefficient of r and you square it, that is what we call the coefficient of determination. And what this is r squared measures the proportion of the variation in the dependent variable that is explained by the regression equation. So what does that mean and what does that look like? Well, what that means, or for example, let's say we had the same example we used with the convenience store manager. Okay, we found r to be something, and then r squared would be 0.9357. So with it being 0.9357, what that means, if we round that as a percentage, we can round that to about 94%. So that means that approximately 94% of the total variation in the number of cans sold is attributed to the temperature. And the correlation coefficient of r would have been just 0.9673. And what this means is that the regression line has a positive slope because it's a positive number, and it's a high correlation because it's very close to 1. So that closely models the data. If it was 1, it'd be 100% correlation. It'd be a straight line for all these points. So it's not 1, but it's very close to 1. So this would be a linear regression example. All right, next we have what's called a quadratic regression model. And what this is we're finding the quadratic equation of best fit for the given data. So just like we found a line to represent the data that we collected, here we're trying to find a quadratic equation that best fits the given data. So an example of this would be right here, where we have the following data representing the approximate heights for a ball thrown by a shot putter as it travels x meters horizontally. Using a quadratic model, predict how high the ball would be after it has traveled 80 meters horizontally. So again, what we can do is we can take all these points, or each line here, each line to create a point. We take all those points and we graph it. All right, and then here we see a curve that kind of goes through that set of points. And again, there's a way we can calculate that by hand, but we'll show you here at the end how we can find this line and the equation of that line, or not a line, but a curve, with Microsoft Excel. But here, for now, we can see that there's an equation that best represents the given data. All right, that equation is y equals negative 0.0111x squared plus 1.0596x plus 0.2422. So that is the equation. And notice, by the way, r squared is 0.975. So what that means, since r squared is 0.975, is that 97.5% of the variation that we see in the data can be attributed to the height of the ball. All right, so that's what that means. And so what we can do, though, is we can take that equation, and we see it here, and we can use this to predict. All right, so we're trying to predict how high the ball would be after it's traveled 80 meters horizontally. So the horizontal distance of 80 meters, that is your x value, right? Because your x values were the horizontal distances, and then the height is your vertical distance. So what we can do is we can plug in 80 in place of x to figure out what is y, which is the vertical distance. All right, so we plug in 80 in for x. We have negative 0.011180 squared plus 1.0596 times 80 plus 0.2422. So if you do the calculations here, you can type it into your calculator, and your answer is going to be 13.9702. You round that to the nearest whole number, that would be 14. So what that means is that your height would be about 14 meters if the ball has traveled 80 meters horizontally. So we've showed you how to interpret these different regression models, both linear and quadratic. We've learned how to interpret the correlation coefficient and then also r squared. Now at this time what we're going to show you is we're going to show you how to create these different graphs within Microsoft Excel. So here within Microsoft Excel, we see our table created. And you could do this in Microsoft Excel. You can use a calculator if you know how to do that. And there's other ways you could do this, but this is one of the ways in which we can create the graph. All right, so what you can do is you highlight your data. So after you put everything in, highlight it. Then you can press Insert. So then you go in here. Within Charts, we see the option for a scatter plot. All right, so let's pick this scatter plot here. Just pick the first one. And notice we have the data points plotted right here. All right, so now what we can do is we can press this plus button, and you can press trend line. And here we have a different options. So we have linear, exponential, and some other options as well. We want a linear model. All right, so it's already selected. That's the default. So here's our line, our regression line. All right, so that's the line, but then you want to know what the equation is. So what you can do is you can click on the data, right click, and then go here. You can click Format Trend Line. So within the Format option, okay, we see these trend line options. So down here, we can display the equation on the chart. So we see that right here. All right. And also, okay, I should go back in there. Also, you can do display the r squared value on the chart. So you can do that as well. You can set the intercept. Actually, let's not do that, but there's different options within here. All right, so that's your equation of the line, and there's your r squared value. All right, so it's very quick. So that's what you saw in the PowerPoint presentation, and that's how we got that. And then from there, you can use this equation to predict different things. And then if you want to do a quadratic regression, so here's the data that we had for that example in the lesson. So here, if we type in the data, do the same process. You go to Insert, you can click here, Scatter Plot, and notice when you plot the points, it looks like a curve. Okay, so same exact steps pretty much. So you go in here, you want to press the trend line option. All right, and then within here, there's different options. So let's just go to more options. All right, so it should pull up. Actually, you know what, let's do it this other way. So let's just right click, Format Trend Line, and then here, exponential is what we want. All right, so we can do exponential, or polynomial might be better. We can do order of 2. All right, so we have an order of 2. That would be a quadratic. All right, is that the same thing as this? Exponential? No. So you want the polynomial one with an order of 2. All right, that's what we want. And then down here, we can display the equation. We can display the r squared value on the chart. And let's get rid of this other one here. That was a linear regression line. We just want the quadratic. All right, so we see right here, this is our equation. And you can make it bigger, smaller, whatever. So we have our equation. We also have our r squared value. So it's very quick within Microsoft Excel to get that equation. And then again, once you have that, you can then use it to predict different values. And that concludes our lesson for today. We will see you next time.